Today I'm going to be going over a Grind 75 premium hard question that I just solved by myself, which I'm really happy about because I struggled with this one for quite a while and I was finally able to do it. So let's go over it. This one's called Employee Free Time. It is a greedy interval scheduling problem, I think. It's very similar to merge intervals if you've solved that one. So essentially you are given a matrix of list of lists that are nested of integers, and they call this interval class an interval object, and it has an API that you're supposed to use. So essentially you want to get any overlap of time. For example, if we have a timeline 1 2 3 4 5 6 7 8 9 10, any gap that's not there, so 3 4 is supposed to be a list in your resulting list that you're supposed to return as an interval object using this API. So if you know that, it's actually pretty simple because you can just create a number line after sorting and then get all the ones that are not covered. And I'll show you how to do it. So first, let's iterate over schedule from left to right. Let's iterate over each sublist. And then the confusing thing is because these are nested, you actually have to iterate over S as well. And now you can get the start and the end. So let's call this TMP. And if we print this now, it took me kind of a while to figure out, but if you print a start and a.end, now you're given the actual intervals themselves. So 1 2, 1 2, 5 6, 1 3, 4 10. And then we can just append this to TMP as so creating our own matrix. And let's print TMP to see. So cool. Now we have TMP. So what do we want to do? Now we want to sort it because we want to basically check for any gaps, which means we first sort by the x-axis. So then if you've done merge intervals, this is pretty similar. When you sort by the x-axis, you know that this has to be larger than this, or this has to be larger than this, and you know that the 0th element is the smallest one. So that allows us to basically go through the list from 1 to the end. And then because the first element is going to be the smallest, the smaller of the two. If the first element is smaller than the last element, the bigger element of the previous, then we don't have any overlap. If this is bigger than the previous, then we do have overlap. So if you know that, now we can go through our, well, first we have to get the smallest one. So let's call this smallest or first equals to a list of TMP0. And now the interesting thing is we have to keep track of the biggest y-axis because, for example, some edge cases I'll show you in a second, but let's try to do this first the naive way. So for I in range 1 length of TMP, so if TMP of I 0 is less than or is bigger than TMP I minus 1 1, as we said, if this element is bigger than this, then we know there's a gap. For example, 4 is bigger than 3, so we know there's a gap. We just get that from looking at the picture. So now we create an answer list, and then we can append an interval object of TMP I minus 1 1 and also TMP I 0. And then we can return answer, which is not correct. This was my initial approach, but I'll show you some edge cases where this fails. In particular, if we copy this, we copy this, and we copy this, you'll notice that we have some intervals that are actually covered. Why? Because we need to keep track of the historical biggest y. So when we get to, for example, 1826, we are going to make sure that this has to be bigger than 25 to be included, which it's not. So that's why we don't want this 18 interval. Okay, and then you're going to do that for the x1 as well. The x1 also has to be bigger than or equal to 25. So you notice that's why 26 and 27 both have to be bigger than or equal to 25, or else you'll get intervals that were already covered, right? So if you know that, let's keep track of the biggest y. And let's set that to TMP01, which is going to start at 2 in this case, or 25 here. And then we're going to update that after each iteration. TMPI1, which is going to be this first index. Okay. And what that allows us to do is compare the correct appropriate thing. So we're not doing this comparison anymore, or we are, but we have to make some modifications. So if let's add, so if TMP of I0 is bigger than biggest Y, and let's print that to C, use this test case. So now we have some improvement, because now we're at least the Y coordinate is correct, because these are flipped around, right? This is actually the current x-axis, and then this is the previous y-axis. And also, let's say and TMP I minus 1, 1 also has to be bigger than the biggest y. Sorry, not this. So if this is the case, then we can print biggest y, TMP I0, and TMP I minus 1, 1, right? Because look, if you see what we have here, the 81 is not correct, right? We have to make a small adjustment. And now you'll notice that the x-axis is actually supposed to be the biggest of these two. So we'll say max of, instead of TMP I minus 1, 1, it's supposed to be the max of these two numbers, right? Which is going to be TMP I minus 1, 1, and also biggest y. Okay. And there you go. That passes, because basically we have to observe here that we want the biggest. So this is the correct one, right? Minus 1, 1 is supposed to be the previous element, and then whatever biggest y is. So we're comparing 81 and 87. Because 81 was already covered, we don't want that there. And then we want the 87 because 87 is never covered here. So hopefully that makes a little more sense, but I'm pretty happy I managed to solve this one on my own, since it's a famous grind 75 question that I was stuck on for a while. So thank you for watching, and please hit subscribe if you find these videos interesting, and stay tuned for more content.